Cool. All right. So I was already going to be between you and a somewhat late lunch, and now I'm between you and an even later lunch. So I will try and be brief, and I will try and be entertaining, and I will, if you all want to, riot and go off, drive me off the stage early, I will not be insulted. But I'm here to talk about the origins of Kubernetes and give you a perspective on the project that I think maybe is a unique perspective on where we were and where we've come. The first thing I wanted to give you the origin of, some of you, if you've seen Kubernetes out there, you may have seen, if the clicker would work, all right, there you go. You may have seen it referred to as K8S. I don't know if everybody has seen the reason for that, but that's the first little thing I thought I would explain, which is, of course, there are 8 letters between the K and the S, so we've shortened that. It's in the spirit of I-18N and many other things. Joe Beta actually deserves credit for that particular one for whatever reason. If you like it, credit to him. If you don't like it, I'll take the blame. I also wanted to actually talk a little bit about the name because we get a little bit, every once in a while, I think at this point it's been in the mainstream long enough that there hasn't really been, I haven't seen a lot of like where'd that wacky name come from recently, although I guess there was a blog post. But the original name that we came up with, that I came up with when was 7 of 9. It's a Star Trek joke. It's a pretty dorky Star Trek joke, honestly. Because it's not just a Star Trek joke, it's actually a Star Trek Voyager joke, which that means you hung on for a long, I admit it, I hung on for a long time. And then that name didn't stick, so it became Project 7, which I also thought was really cool because what happened to the first 6 projects? But that name didn't stick either. And so we were headed towards launch and we needed a name, and Craig actually was the one who came along and gave it the Kubernetes name that turned into a thing. And it's funny to see a word go from being something that we were bandying about in email saying is this the right one? Is this the right fit? Are there any existing trademarks? To being something that has become so integral to everything that I've done for the last 3 years and become a really important word to me. So that's a really interesting migration. So that's a little bit of a touch of the personal history, and we'll go back into some of the more real history, the prehistory, if you will. And so in 1979, that's the introduction of chroot, which is, I think, the beginnings of all of this, right? And I would like to claim responsibility, but I was 3 years old at the time, and I don't think that, I tried to find a picture, because it's a great picture of me chewing on a rock, but I couldn't find it. It's somewhere in my mom's basement, I guess. chroot made its way into BSD in 1982, and then FreeBSD had this idea of jails, and there's the first place, I think, where we're moving from a chroot, which is really kind of a convenience or security by obfuscation, to a place where we're actually talking about isolating things from one another. And Solaris zones and containers followed, and then eventually Linux cgroups and namespaces, the beginnings of that support inside the namespace. Interestingly enough, the Linux work that happened mostly was based on resource isolation as opposed to security isolation. And so there are sort of these 2 different threads of how you might build containers that go forward into these different operating systems. At the same time, interestingly enough, at the same time as cgroups and namespaces are entering the kernel, AWS starts selling VMs, right? And I think that this is really important because if we're talking about where we are now and the origin of Kubernetes, it's really the marrying of some technology and some ideas around resource isolation and application packaging and cloud. And I don't think the system exists without both of those things, right? I think that in many ways, and people keep using the word cloud native, which I think probably in a few years is going to be almost as hated as DevOps, but I think that there's this notion, actually, that a lot of this technology is built for the cloud, is a natural fit for the cloud. And so I don't think you can really talk about the origin without talking about both the technological origin as well as the transition of how we actually build software. And then there's a little bit of the personal as well, which is in 2008, I left academia. I left Schenectady, New York, which is upstate if you live here and downstate if you live in Albany, or excuse me, in Rochester. And I joined Google's web search infrastructure teams. And that's sort of where the story actually kind of begins. And so I want to talk a little bit about my ops experience as a web search infrastructure engineer, because I think that this really forms a personal portrait, but actually a characteristic representation of what I think all of us are striving for. And this was mentioned before in the Ticketmaster talk, and I think it's critically important, this sort of point number 1, which is no SSH. I didn't say RDP because I wasn't thinking about Windows, but no SSH, no RDP, you don't get into the machines. The only way in is through an API, right? And I actually lived that, right? critical web search infrastructure on call for that, and I probably could count the number of times I SSH into a machine in maybe one hand, probably less than one hand, over across 4 years, right? The way you interact with the system is via the API. This means the system itself is immutable, it's well understood, you don't end up with weird situations. In fact, it used to be the case actually that you could go and flick command line flags on binaries via a web interface. And they actually turned that off because it turns out that flicking flags on binaries via web interface is very much like SSHing into that machine. You're making these imperative changes that don't stick around for the next rollout, and that's a recipe for failure, right? And this notion of imperative configuration being something, a central sort of evil to avoid, is something that I think carries throughout all of this as well. And then you might think that this is a place where there's no room for error, but the honest truth is there was actually a lot of room for error. And one of the most proud, you get these little trivia badges. I think a lot of places have these sort of like little trivia badges that you get. One of the most proud is the one that I have for bricking a search data center. True story. But the truth is nobody noticed, right? Like none of you noticed, right? And that's amazing, right? It's amazing that this infrastructure not only makes it easier for you to roll out software, but because it's easier for you to roll out software, it makes it easier for you to roll back software. And so you can make a lot more mistakes because the record of what you did and the path back to where you were, where it was working, is that much easier, right? And I think that that's hugely important. It's not just about improving utilization and developer agility. It's actually about building safer processes for building out your reliable systems, right? And I think that's something we always have to keep in mind as part of what we're doing. We're not just building out things that enable you to use your data centers better or enable your developers to deliver code more quickly. We're actually also trying to make the services that you build more reliable. Because at the end of the day, we've passed the world. Actually, every once in a while, I run across these websites where they're like, it's midnight, and we're doing our nightly upgrade. And it's like, what? Am I back in 1997? And we no longer live in a world where it's OK to be doing a nightly upgrade, right? You have to be doing a rollout that nobody notices. You have to be making mistakes that nobody notices. All right, but throughout this process, I was using Borg, right? Borg was the internal container orchestrator, and across this process, I don't know why, I don't know why I was focused on it and was interested to it, but I always had ideas, like you're at the lunchroom conversation or whatever, and like I would always be complaining about pieces of it or thinking about ways in which it could be done differently and things like that. And so I'd spend a lot of time both using this system at a very high level. And I had thought a lot about the bits that I liked and the bits that I didn't like. And I don't know, just like anything else, when you sit with tools for long enough, it's like an old married couple, right? You really have this relationship with the tooling that you're using. And so I wanted to take a brief moment and talk about Borg. It's really important to say that this is something that I used. This is not something that I built, right? This system predates me joining Google. It was the merger of two systems. One was Global Work Queue, which was basically a batch infrastructure for running batch jobs across a fleet of machines, and this thing called Babysitter, which was basically a Python script that restarted things if they crashed. Right? So those were sort of the two pieces. One was used for live running servers. One was used for batch infrastructure like MapReduce. And there was this notion that these things should be brought together. And the result of that bringing together was Borg. But what happened was, because it was really brought together specifically to kind of merge these two systems, and not necessarily with an idea that it was going to become a software development platform, there was a ton of organic growth that happened over time. Right? And I'll talk later about some of the unsolved problems that we ran into, but one of the things is there's sort of I think everybody sees this in a lot of different areas, there's always sort of a flavor of the month. And in the particular case of Borg, the flavor of the month was configuration languages. And so you would end up with this system where the load balancer has a different configuration language than something like Bigtable has a different configuration language than Borg itself. And it was just this sort of organic collection of stuff. And then a team would go off and build a really useful service, and then the rest of the company would adopt it. And so it was this sort of organic growth of useful pieces, all with slightly different ways of being configured, that ended up being the system that I used to deploy web search. And also, it had this focus on utilization. Right? It was hyper-focused on driving up the utilization of the fleet, which is an awesome thing to do. but he's probably not the #1 problem for most developers in the cloud, right? Agility is way more important than utilization. And I think those are important things to draw in contrast, because when we start talking about Kubernetes and some of the things that influence the development of Kubernetes, you'll see the contrast that we sort of started to bring out. All right. So at the same time, in 2012 in Seattle, web search left Seattle, which made me pretty sad. But public cloud was growing in Seattle. So I joined public cloud, which made me happy. But public cloud was still using VMs, which made me kind of sad. But we can try and make it better, right? And so my first introduction and my first really exposure to cloud was taking VMs as a given. I didn't see any way to bring people into containers. VMs were the thing that people were using. Chef and Puppet and Salt were the popular tools for doing this. And I started saying, well, can we take some of those primitives around immutable infrastructure, declarative configuration, doing deployment server-side in a process that moves towards a goal rather than something that runs on your laptop? Can we do some basic health maintenance? Like, are there things that we can take from the world that I had experienced into the world of VMs and make them happen? And I started to build some of that infrastructure, and I started to build some of that tools. And then this amazing thing happened, which is that Docker happened, right? And I was telling someone the other day that I really believe that Docker is the black swan, right? Like, I don't think this was one of these things that was going to just happen no matter what. It fit its moment really well, but the unique characteristics of the tool also created an environment where it just exploded, right? It's an amazing thing because it opened all of these. I think it revolutionized computing, and I think we should be incredibly grateful to those folks in that team for developing that thing. And in particular, they had 3 pieces that they put together that I think became the real crystallization of the experience. And I think if you don't have all 3 of these, I think it doesn't go, right? One is that they built this image format and build tools, right? They met people where they were. I don't know how many people started using Docker in this time period, but does anybody remember that there used to be instructions about how you built an image, which was like, start the image. OK, now you're at a shell prompt. Now run apt-get. Now run apt-get. Now edit this thing. OK, now exit the image and say, archive that thing, right? I don't think those docs even exist anymore. But it was an amazing thing that met these IT people where they were and brought their existing skills along. And I think that's a huge lesson for all of us, right? Nobody adopts new technology if it makes them feel less empowered than the old technology. Right? Nobody likes feeling like they can't do what they need to do. You have to meet people where they are. And the next piece is this: they built this image distribution infrastructure, right? It suddenly, like, the problem of getting the bits to the machines just got solved. And it got solved in a reliable way where a script didn't fail halfway through, right? That was a huge advance, and I think another reason why people did it. And then finally, they built this containerized runtime that allowed for things like the utilization, allowed for health checking of the process, and a bunch of other pieces that happened on the machine. But honestly, I think the first 2 are the more critical piece, right? The container runtime itself, like, it's necessary and it's very useful. But I think if you don't get that image format and you don't have a developer experience and you don't make it super easy to take that image from your laptop out to the world, I don't think any of this stuff happens. Right. And so then I wanted to take a brief step back to my own, I'll draw it back to my own personal experience a little bit. So we'd seen this come open, we'd seen containers, we realized that this was suddenly this opportunity to sort of bring the worlds of the way that we had done compute internally with the way that we were going to do the world of compute externally. We had started to play around with some of these ideas, trying to figure out what's going on. And as part of this, I went to the first Docker meetup in Seattle. And I remember it very distinctly because I came out of that meeting with this intense feeling of both anticipation of where it was going and real concern about how we could possibly get there. And in particular, it seemed absolutely critical to me that the only way to achieve the kind of velocity and meeting people where they were and understanding of the product was to build an open source solution. And this was, in some respects, a kind of big undertaking because for a long time, the Borg system itself was sort of considered the secret sauce. In fact, the Borg paper that was written for people actually came out after Kubernetes was released, right? And so we really hadn't talked about this whole thing very much. And so I had this idea that we needed to build a minimally viable open source Docker orchestrator, but there were 2 challenges. One of them was the pointy-haired bosses, who we had to convince that this was an okay thing to do. And then one was writing the code. And I'll just say that writing the code was a lot easier. But we got it through and we got it done, and we announced the open source orchestrator. And the truth is that like the orchestrator that we announced is a pale shadow of what it is now, right? And a pale, because all of those commits that David showed earlier, every single one of those came after we started the project, right? And so it's incredible to see how the notion that we could sketch something, could sort of put a flag out in the distance and say, hey, everybody, come with us, has turned into this thing where you guys have come and to listen to not just me talking about it, but all of these other people who are using it and using it to power their production services, and that's pretty amazing. So I wanted to talk about what I meant when I said a minimally viable open source Docker orchestrator. The first thing is that ops had to be simplified, right? The complexity associated with running n of a thing had to be the complexity of running one of a thing. I think that's one of the primary goals behind what we're trying to do. In order to scale, in order to deploy services that are reliable, you have to be able to scale your application without scaling your operations. And that's one of the main drivers that we're about. The next thing is we need to decouple all the things. I think that this picture has actually been in, I think, practically every talk I've ever given about Kubernetes, so you've probably all seen it before. Coupled systems are inherently fragile. Someone said earlier 50% of what they did was self-inflicted. And I would argue that yes, 50% of the errors that you cause are self-inflicted, but most of the errors that are self-inflicted are caused by something that you didn't anticipate. Some coupling on some other system because you looked very carefully at this change, you just didn't realize that this change was attached to this other piece of system over here, right? And that's because the system is coupled in ways, and coupling inherently makes your system more rigid and harder to control, just like the semi-trailer here that has gotten jackknifed in the ice. So we built the system to be decoupled, to be modular, to allow you to opt into various pieces. This was colored as well by our experience with PaaS products and how they're wonderful until they're not. And it's very important that the escape route look more like firing the gardener and having the lawn get a little longer each week until you learn how to mow, rather than jumping out of a plane without a parachute, right? And that's another piece of decoupling and modularity that we're trying to achieve. And then another piece of the minimally viable Borg was this notion that we need naming, right? Like suddenly we're moving from a world where machines have names. Now you have this container, it kind of floats on these machines, it's not really associated with a machine. If you don't have a name for that thing, it becomes very hard to find, right? And so we needed to have naming as part of the system. And as part of that, we also needed to have discovery, because it's one thing to have everything have a name, but you also need to go from that name to find the running thing. And so the notion of making ops easier, decoupling all the systems, enabling us to name our things and then discover those names really became the basis of the product that became Kubernetes. But there were also some lessons that I had learned and that others had learned along the way from operating Borg that fed into the system as well, right? And one of those was to be consistent, right? I mentioned earlier there's this massive heterogeneity of how you configure things and how things look. One of the things that we've tried very hard to achieve inside of the Kubernetes API is that objects are consistent, patterns are consistent. So you see the same patterns, the same ideas repeating over and over again. This is important because that means that the knowledge you learn in one object transfers to an object that you're just learning about. It means that the pattern for how the system behaves in one area transfers over to debugging how the system behaves in another area. This kind of consistency and sort of holding together of a coherent system becomes incredibly important when a lot of what we are trying to do is actually help people with this transition from previously generations of their infrastructure to new container orchestration. Another important lesson was that everybody comes in the front door. Right? This was actually not true in early prototypes. We actually had some back doors where people would listen directly to etcd, or where people would be talking to some private APIs that we had built for expediency. And over time, these all got ripped out in favor of every single component inside the infrastructure going in through the main API front door. This is hugely powerful, hugely important. I highly recommend it for every system you ever build. There is no excuse at this point. We build so many APIs. There is no excuse for not using all of those APIs that you built yourself. Never, ever, ever go directly into storage. Never, ever, ever have private APIs that only your services can see. And then finally, one of the most important lessons is that there is no hierarchy, right? And this is the idea behind labels. So labels become this organization primitive that helps all of the objects that we have, again, going back to consistency, helps all of the objects that we have in Kubernetes be groupable and be organizable. And the real lesson here is, I have lots of containers maybe, and I have a bunch of different labels that I can put on them. And really, there's a lot of different ways that I can try and analyze that, right? So for example, I may want to take a role-oriented view of the world, right? I may want to group things by their role. These are all my front ends. These are all my back ends, right? I may also want to take a machine-oriented view. Maybe I think that a machine is sick. I want to see how all of the tasks on a particular machine are doing. Right? So you can see here that role view and the machine-oriented view are explicitly at odds with each other. And even beyond that, I may actually want to take a user-oriented view, right, where I see yet another view where I'm seeing the things that I created or the things that another person on my team created. Right? So there are all of these different perspectives that I may want to take onto my infrastructure. If I establish a hierarchy where objects own other objects, where there is an explicit relationship as opposed to an implicit query-based relationship between objects, you can't express the full fidelity of the different perspectives that you may want to take on your infrastructure. So labels become this hugely flexible, powerful way of organizing all of your infrastructure and yet not having a pre-established hierarchy that you have to fit into. All right. There are some differences as well, and one of the main differences was that it had to be public cloud, right? We had reached a place as an industry where it was very clear that the cloud was the future. This only continues to be more and more true, right? Where everything that most of the major cloud software companies are doing is focused on figuring out how to grow their cloud. So we knew that it had to be a cloud. That meant a lot of different things. It meant we couldn't, I like to say in public cloud, you have about 2 hours to convince someone to use your product before they move on, right? That's massively different than if you're building a product that is the monopoly IT solution for a large company. Another difference was that it had to be open, right? I think this is taken for granted at this point. 3 years ago, it may not have been quite as taken for granted in public cloud. At this point, I think it's very clear infrastructure has to be open source. This level of infrastructure has to be open source. There is too much of fear of lock-in into a predominant vendor. We have to have portability between clouds and let people win based on their technology as opposed to the APIs that are exclusive to that cloud. And then the final piece is we needed to build this community and this ecosystem, right? We needed to solicit help from a lot of different people because we knew that we didn't have all of the answers. And so building something from the ground up, in some ways going out with something that was immature, unformed, that needed a year. So it took us a year from the moment where we released to the moment where we got to a 1.0 product. We did that all out in the public. And we continue to do all of this work out in the public to the point where I can switch, from one public cloud provider to another public cloud provider and continue to be up on this stage and continue to be participating in the community because we have built this ecosystem, because it's truly a vendor-neutral place to be. That was hugely important. So 3 years later, we have many, many clusters in production. Many of them are your clusters. David mentioned a lot of this stuff, 40,000 commits, 1,000 contributors, 191 meetups around the world. I don't think there's a single meetup that we were ever directly responsible for. It was entirely organic, so thank you to every single one. I know Matt is here from the Seattle meetup. A lot of other may have been creating meetups as well. Thank you so much for that. And I will say, and I didn't clear this with them, but I'm sure that they will say this as well, but speaking on behalf of Craig and Joe, we are incredibly humbled. Every single time I come to an event like this, it is amazing. Someday maybe I'll get used to it, but not yet. Right? It's amazing to see people who are willing to bet on this idea that we had 3 years ago. I wanted to close with some of the hard problems that I think are unsolved, because I think that it's great to talk about the origins, but I kind of wanted to bring it home with some of the things that I think we still need to work on. And so the biggest one out there is configuration. Right? This is like the third rail, as far as I can tell, of all systems that I've ever built, right? Which is that every single person has a different way of doing it. I mean, this is seen in all the DevOps tools and everything else. How do you do configuration of your application, right? It's a totally unsolved problem. I think maybe it's unsolvable in the same way that programming languages are unsolvable. There may just be 2 or 3 different approaches, and they fit different aesthetics. But even with the 2 or 3 different approaches, I think we haven't gotten there. Some of the things that I'm most interested in are the idea that we may actually be able, that the divorcing of code and configuration may have actually been a bad idea, and may have actually been an accident of timing rather than an actual design decision, trying to see if we can maybe bring those things back together so that you describe your infrastructure in the same place where you write your code, so you can build self-deploying applications. Kelsey Hightower has been experimenting with this as well. And in particular, it's because your app knows. I mean, it's not like you were going to give that app a different topology, right? The app only works in a particular configuration. So describing its topology in one place and describing its function in another place just doesn't make sense, because you've already implicitly described its topology in the application that you've programmed. Another really important unsolved problem that I'm particularly excited about pursuing is cloud development. How many people out there are happy with their cloud development experience? Right? I don't see any hands, right? And I think that this is true, right? Like, how many of you still use print line debugging? Yeah? I see some hands. I use print line debugging for my entire career in distributed systems, right? I'm not ashamed to admit that. I do wish that there was something better, but I don't know what it is, right? And I think that there is this notion. It took a long time to go from programming. I mean, I don't know where you want to start the clock on programming, but to the evolution of modern IDEs in sort of the mid-'80s to early '90s, where I think we hit an apex in terms of development environments for building single machine applications. And then it turned out that single machine applications were not as useful anymore. But we haven't hit that place where we have a great development environment for cloud applications. And I'm really interested in exploring what that looks like. And then the last problem I think we have is we're reaching a place where we need to figure out how to scale this project for our community. We have 1,000 contributors. We have 1,000 people who have participated. We have many, many thousands more who are using this product. We're hitting a place where scaling that community becomes a significant challenge. And I invite all of you to help us along that journey as we go from being a project that is developing to a project that is mature and moving forward. So that's it. Enjoy lunch. Thank you so much.